Good morning all. Now I am going to explain about input and output characteristics of transistor in CB configuration. That is nothing but common base configuration. Now see the circuit diagram of a CB configuration, right? In this first one we need to calculate input characteristics. Okay, input characteristics are plotted between input voltage versus input current by maintaining output voltage as constant. In this common base configuration, VBE is the input voltage, IE is the input current, whereas VCB is the output voltage. Okay, now see here from this circuit diagram, first RPS, right? This is RPS. Okay, I am using 2-channel RPS. Next, input side ammeter, input side voltmeter. Next, here output side voltmeter. Now see here, first of all, RPS negative is connected at one point. Okay, RPS negative is connected at one point. At that point 1 kilo ohm resistor starting point is connected. Okay, next 1 kilo ohm resistor ending point is connected at one point. At that point input side ammeter positive. Okay, next ammeter negative is connected at another different point. Ammeter negative is connected at another different point. At that point voltmeter positive. Next see here, at that point only transistor emitter is connected. Now see here, this is the transistor. Okay, in this transistor, okay, the terminal which is having notch, okay, see here there is a notch is there, that terminal is emitter. Okay, after that the terminal which is nearer to this emitter is nothing but base. Now see here, the terminal which is nearer to the emitter is nothing but base. That means this is emitter, the terminal which is having notch is emitter, the terminal which is nearer to this emitter is nothing but base, then the remaining terminal is collector. Okay, now see here, first of all this is emitter, right? That means emitter is connected at ammeter negative point and voltmeter positive point. Right, this is emitter, base, collector. Now see here, this base should be connected to ground, right? That means here base is connected to ground. Ground I am using here. Okay, base is connected to ground. Next, at collector terminal voltmeter positive is connected. At collector terminal voltmeter positive is connected. Next, voltmeter negative is connected to ground. Voltmeter negative is connected to ground, right? At that point only another 1 kilo ohm resistor starting point. Next, this 1 kilo ohm resistor ending point is connected at one point. Okay, next at that point second channel RPS positive is connected. Next, second channel RPS is connected to negative. Okay, next, now see here input side voltmeter negative is also connected to ground. Next, first RPS positive is connected to ground. Okay, ground is having 3 conductors, 3 wires side, 1 2 3 4 5, 1 2 3 4 5, right? Now connections are over, right? Okay, now coming to the procedure, connections are made as per the circuit diagram, right? Switch on the power supply, switch on the power supply. Now see here, in this input characteristics we need to vary the input voltage in steps of 0.1, 0.2 something up to 0.7. okay, now see here, Here I am varying the, you can see the tabular form. Can see the tabular form, right? Input characteristics are drawn between input voltage versus input current by maintaining output voltage as constant, right? First case VCB, this is output voltage is taken as 0, right? After that, next I am varying the RPS voltage in steps of 0.1, right? Here voltage 0.1, current is 0, 0.2, current is 0, 0.3, current is 0, right? 0.4, current is 0, 0.5, current is 0, right? Next 0.6, 0.6, current is 0.2 or 0.3. Next I am increasing this current to 0.7, right? Then the current is 1.9. Next I am increasing the supply voltage to 10 volts. Now see here current voltage across transistor is 0.7 only, current is 4.5 milliamperes. Next again I am increasing the supply voltage to 15, right? Voltage across the diode is voltage across transistor is 0.7 only, but current flowing through the transistor is rapidly increases. That means in case of input characteristics, these characteristics are similar to PN junction diode forward bias characteristics, right? Now if I am giving 20 volts, right, voltage across the transistor is constant. That means these characteristics are similar to PN junction diode forward bias characteristics. After that, next reduce this RPS voltage to 0, okay, and vary the, right? Yes, first case we need to set VCB is equals to 0 volts. After that VCB is equals to 5 volts, right? That means I need to change, right? This is output, right? Output means I need to change the channel position, channel 2, okay. Set channel 2 voltage to 5 volts. Now observe here, this is VCB, right? Right, here VCB is equals to 5 volts. Now see here VCB is equals to 5 volts, okay, by maintaining output voltage as constant. Next again I need to apply input voltage, right? Now see here I am varying the RPS voltage, right? Again minus 0.2, 0 only, 0.30, 0.40, 0.50, right? 0.6 or 0.5, 0.2, next 0.6, 1.5. Again I am increasing the supply voltage to 10 volts, right? The voltage across transistor is again 0.7, but current flowing through the diode is transistor is rapidly increases, right? Next vary the RPS voltage to 15 volts, right? Voltage across the transistor is same, right? Same as PN junction diode characteristics under forward bias, right? 15 volts, right? Voltage is constant, current flowing through the device is increases, right? Okay. Next again after that reduce RPS voltage to 0, right? After that again I need to apply another VCB voltage, that is 10 volts, right? Here VCB voltage will be 10 volts. That means by maintaining output voltage as constant, right? Next vary this output voltage to 10 volts, right? Set output voltage to 10 volts. After that again comes to input, okay. Again by varying RPS, and voltage across the diode will be in steps of 0.1, 0.2, right, up to 0.6 or 0.5, very small amount of current, that is 0.1. After that, right, voltage across transistor is 0.6, current is 1.3. Again I am increasing RPS voltage, right? 0.6 only, current is 2.8. Next 10 volts, current is rapidly increases. Next 15 volts. Okay, next 20 volts. Okay, in this way we can do the experiment. Okay, after that if we draw the graph between input voltage versus, see here, input voltage versus input current by maintaining output voltage as constant. Okay, in this way you will get the graph. Okay, when we increase input voltage, see here previous case current is increasing at 0.6, after that 0.5, approximately here also 0.5. okay, in this way we will get the input characteristics of a common base transistor. After that reduce RPS voltage to 0, similarly output side also 0, and switch off the power supply.